The life of Sir Isaac Newton is a fascinating journey through one of the most brilliant minds in human history. Born on Christmas Day in 1642 in Woolsthorpe, Lincolnshire, England, Newton entered the world as a weak and sickly child. His father had died before his birth, and his mother would soon remarry, leaving young Isaac in the care of his grandmother. From these humble beginnings, Newton would rise to become one of the most influential scientists of all time, fundamentally changing our understanding of the physical world and laying the groundwork for modern science. Newton's early years were marked by solitude and introspection. As a boy, he showed little interest in the family farm but displayed a keen mechanical aptitude, constructing miniature windmills and sundials. His uncle, recognizing the boy's potential, convinced Newton's mother to send him to grammar school. At King's School in Grantham, young Isaac's academic talents began to flourish. He was a diligent student, often lost in thought, working on mathematical problems or sketching elaborate designs in his notebooks. It was here that Newton first encountered Euclid's elements, sparking a lifelong passion for mathematics. Newton's time at King's School was crucial in shaping his future. He wasn't the most social child, but his mind was constantly at work, grappling with complex ideas far beyond his years. In 1661, at the age of 18, Newton entered Trinity College, Cambridge. Initially studying the standard curriculum, he soon became fascinated by the more advanced science and mathematics of the time. Newton voraciously read works by Descartes, Galileo, and Kepler, among others. He filled notebooks with his thoughts and discoveries, including one titled Questions Quidem Philosophicae, certain philosophical questions, which hinted at his future revolutionary ideas. In 1665, Cambridge University closed due to the Great Plague, forcing Newton to return home to Woolsthorpe Manor. This 18-month period of isolated study, often called his Annus Mirabilis or Year of Wonders, proved to be extraordinarily productive for the young scholar. During this time, Newton made groundbreaking discoveries in mathematics, optics, and gravitation. He developed early ideas on calculus, began his experiments with prisms and light, and first conceived of gravity extending beyond Earth to hold the Moon in orbit. The work Newton did during his time at Woolsthorpe laid the foundation for his most famous discoveries. It's remarkable to think that a 23-year-old, working in isolation, could make such profound breakthroughs. Returning to Cambridge in 1667, Newton was elected a Fellow of Trinity College. In 1669, he became the Lucasian Professor of Mathematics, a prestigious position he would hold for the next 3 decades. Over the next few years, Newton built the first reflecting telescope and developed his theory of color based on prism experiments showing that white light is composed of a spectrum of colors. In 1687, Newton published his seminal work, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, often simply called the Principia. This monumental book laid out Newton's laws of motion and universal gravitation. The Principia explained diverse phenomena like planetary orbits, tides, and the trajectories of comets using a unified mathematical framework. The Principia revolutionized our understanding of the physical world. Newton's other major scientific work, Optics, was published in 1704. It detailed his experiments with light and color and proposed a corpuscular theory of light. Newton also made significant contributions to mathematics, co-developing calculus independently of Leibniz, leading to a bitter dispute over priority that lasted for many years. Beyond his groundbreaking work in physics and mathematics, Newton had deep interests in alchemy and theology. His alchemical pursuits, while less known during his lifetime, were extensive and influential in his overall worldview. Newton spent countless hours experimenting with various substances, searching for the philosopher's stone and trying to uncover the secrets of matter's transmutation. These pursuits often informed and influenced his theories. Newton's work in alchemy wasn't just a side interest. It deeply influenced his scientific thinking, particularly his ideas about forces acting at a distance, which was crucial to his theory of gravity. Theologically, Newton's views were complex and often unorthodox. He wrote extensively on biblical interpretation and prophecy, though most of these works remained unpublished in his lifetime due to their controversial nature. Newton rejected the doctrine of the Trinity, a view that would have been considered heretical by the Anglican Church. This necessitated keeping his true religious beliefs private to avoid controversy and potential persecution. Newton's philosophy emphasized empiricism and inductive reasoning from observations. He famously stated, "Hypotheses non fingo, I frame no hypotheses," eschewing speculative explanations not grounded in experimental evidence. Newton saw the universe as following mathematical laws set in place by God. He viewed space and time as absolutes and believed that God occasionally intervened to keep the cosmos in order. In later life, Newton moved to London, becoming Warden of the Royal Mint in 1696 and Master in 1699. In these roles, he applied his scientific acumen to improving the quality and security of English coinage, ruthlessly pursuing counterfeiters. Newton was elected president of the Royal Society in 1703, a position he held until his death. He was knighted by Queen and in 1705, becoming Sir Isaac Newton, a rare honor for a scientist at that time. Newton's work at the Mint and his presidency of the Royal Society show how he applied his brilliant mind to practical matters. He wasn't just a theorist. He was deeply engaged in the scientific and economic issues of his day. Throughout his life, Newton engaged in numerous scientific disputes, the most famous being the calculus priority dispute with Leibniz. These conflicts revealed a side of Newton that was fiercely protective of his work and reputation. Newton never married and was known for his modest lifestyle despite his fame and the honors bestowed upon him. He maintained close relationships with a few individuals, including his niece Catherine Barton and her husband John Condit. In his final years, Newton suffered from various health problems but remained mentally active. He continued to work on revisions of his major works and corresponded with scientists and theologians across Europe. Newton died on March 20, 1727, in London. He was buried in Westminster Abbey, an honor reserved for Britain's most notable figures. Isaac Newton left a vast and enduring legacy as one of history's most influential scientists. His work laid the foundations for classical mechanics, optics, and mathematics that shaped the course of science for centuries to come. The Newtonian worldview, which presented the universe as a rational, mechanistic system governed by mathematical laws, profoundly influenced not only science but also philosophy, theology, and the broader intellectual culture of the Enlightenment. Newton's integration of science, alchemy, and theology created a unique perspective that continues to fascinate scholars across disciplines. His ability to synthesize empirical observation, mathematical reasoning, and theological reflection produced insights that went far beyond the boundaries of what we now consider science. Importantly, Newton recognized the distinction between scientific inquiry and religious belief, anticipating what the late Harvard paleontologist Stephen Jay Gould would later term non-overlapping magisteria. Newton did not view science and faith as diametrically opposed, but rather as complementary ways of understanding the universe. When he made groundbreaking mathematical discoveries, Newton did not use these to dismiss the need for God. Instead, he marveled at the intelligence of a creator who would design the universe in such an elegant and mathematically consistent way. Newton's ability to hold both scientific and religious views, seeing them as complementary rather than conflicting, offers a nuanced perspective that remains relevant in today's often polarized debates between science and religion. In conclusion, Isaac Newton's life was characterized by a relentless pursuit of knowledge, both scientific and divine. His work fundamentally changed our understanding of the physical world and laid the groundwork for much of modern science. At the same time, his theological and alchemical pursuits reveal a man deeply engaged with questions of meaning and purpose in the cosmos. Newton's legacy reminds us of the power of human intellect to uncover the workings of nature, while also highlighting the complex interplay between scientific inquiry, philosophical speculation, and religious belief that has shaped the history of human thought. As we continue to explore the mysteries of the universe, we stand on the shoulders of giants like Isaac Newton, whose brilliant mind and tireless curiosity continue to inspire scientists and thinkers to this day.